Okay, everybody. It's now 1400 UTC +1, so we will start our penultimate session of ENOG 17. Just a reminder to make sure that you're on the correct language channel, so one for English and one for Russian. Click on the flag at the bottom. I think if you change channels, you may need to exit and come back in again, but just check that you're on the right language channel. Okay, so our first presentation is by Nico Stateless, which I may have pronounced wrong. I hope I've got it nearly correct. So his affiliation is the Swiss Federal Institute of Technology in Zurich. And Nico recently completed his Master of Computer Science, but he's also the CEO of Untitled, which runs a IPv6 and open source compliant, environmentally friendly data center. But today he's going to be talking about high-speed NAT64 with P4. So over to you, Nico.
Thanks a lot. Again, thanks a lot for having me. It's always a pleasure to talk about IPv6 and related things. Not only because it's cool and new technology, but also because it's actually a lot of fun. Yeah, so today I want to talk a little bit about high-speed NAT64 with P4. For those who are not yet sure what is NAT64, what is P4, don't worry, I'll explain about this in detail. First of all, let's have a look. What is the motivation to approach this whole thing? So as of October this year, or even November right now, worldwide, we have something around 0.39/8 IPv4 networks still available. That's worldwide. So accumulated from RIPE, from UPNIC, from AFRINIC, LACNIC, and I missed one of them, sorry. So basically, what I'm saying is, and what you probably all know, we are really, really short in IPv4 addresses. This is no news. What is news that, well, we have announced, everybody has announced this already quite some times, we will run out. The RIPE region ran out last year of IPv4 addresses. We see now at Google around 33%, so like more or less 1/3 of the traffic is now IPv6 traffic going to Google. And we need somehow to bridge the gap. We need to arrange between the old IPv4 internet and the new IPv6 internet. The method how we do this, it's called NAT64, which translates either stateful or stateless from and to IPv6 and IPv4. So how does this work? You know, in theory, well, what can we actually do there? And it looks a bit technical. It is a bit technical. The point is, in general, IPv4 and IPv6 are incompatible. They are two different protocols. And you see on the right, the two different headers. Obviously, the IPv6 header must be bigger because it has much bigger addresses. But what's also interesting, like when you look at the packets on the wire, you actually see that you have an Ethernet packet, you know, that's on the cable, that's actually around your IP packet. And even there, we actually already indicate the next packet is actually IPv4 or IPv6. So when you want to change from v4 to v6 or vice versa, you don't only need to concern yourself about the IP translation, but also about the Ethernet frame around it. What comes also to it is there are checksums in IPv4. They are not in IPv6, but there are checksums in TCP and UDP. So, and those checksums, they include the information, like in TCP, it includes information from the IP header. So when you modify the header and when you go to different protocol, well, all your checksums are not correct anymore. So NAT64. NAT, probably everybody knows by now, is network address translation.
Nika, sorry?
Yeah.
We've lost our translation channel.
Oh.
Could you please wait a little bit to wait until our technical staff will restore this, because now we are living without Russian translation.
That's not good. That's not good.
Yeah, definitely. Several minutes, please. I will let you know when we are ready.
Sounds good. No problem. I can dance a little bit or similar things meanwhile.
Oh yeah, go ahead. Yeah. That's right after all.
Okay, I'm back. If you can restart, maybe well, I don't know. Maybe we can start again. The translator is back. That is to say.
It's back.
Okay. So yeah, we can continue. Thank you.
Okay, thanks a lot. So I just stopped at NAT64. Just a short recap. I think everybody knows NAT, which is network address translation. The 64 indicates we translate from and to IPv6 and IPv4. And as I mentioned before, for doing this in a regular network, you not only have to change the actually IPv6 and IPv4 headers, but also the Ethernet protocol. And you also need to modify, depending on what you're actually translating, you need to modify the TCP header, the UDP header. If you're having, for instance, a ping request, well, that's ICMP, but only ICMP if you're in the IPv4 world. So if you are switching from IPv4 to IPv6 and you have a ping request in there, well, you also need to translate the higher level protocol from ICMP to ICMP6. And when you receive the reply, well, you just do everything around again. Right, so this is no magic in a way. It is just something that we need to consider here. Now, how do we do this efficiently? And there's something interesting, and it has been on the market for a bit of time, but it's not so well known yet. It's a programming language named P4, and P4 is a protocol-independent programming language. It basically allows you to define a packet that might be Ethernet. You just say like there are some bits, and those bits are this and this orientated. And you can say, well, that is what I consider an Ethernet frame. After the Ethernet frame, you can go further. Before I go more into the details, let's have a look like how you actually approach P4. For P4, there's a software emulation. It's called BMV2. This you can run on your machine. I'm using Linux here. I assume it will also runs on Windows. I actually don't know. It is really easy. It's really fast for prototyping. It's very lightweight, so you can just go ahead. It also has some features which we will see later hardware doesn't support. For instance, building checksums over the payload of a packet. So you have the headers, and after the headers, you actually have the content that you really want to send. Then on the other hand, the work I've done was running on a NET FPGA. You see it on the right hand. It's a network card, which is actually an FPGA. So if you want to run P4 on it, an FPGA is it's a field programmable gate array. So it's basically a logic computer that you can define all the different transistors or registers in there. However, P4 is quite a high-level programming language. So if you want to run P4 on an FPGA, you compile it first to PX, it's an intermediate language, then to HDL, and the HDL compile process actually outputs a bit stream, which then again you upload to the memory inside the FPGA, which is then actually your logic board, if you want so. The cool thing is, both in the P4 world, you get a nice guarantee. And the guarantee is within the constraints of the P4 programming language, the code you write will run at line speed. This card here has 4 times 10 gigabits NICs. You can, in theory, and with a little modifications for different hardware targets, because they're not exactly the same, you can you can almost identically run the code from the NET FPGA and the BMV2 on a 100 gig or on a 1 terabit interface, depending on what you have. This is the interesting thing about P4. You don't modify your code. You don't need to change timings or anything. You just natively run on the next target. The language itself, I already said it, it's protocol independent, so you make up your own protocols. What is interesting, like from the way how it works, basically first you have the parser, where you define, as I said before, like this part is my Ethernet frame, this is where's my IP stuff in there. And then you basically use something which is a bit similar to databases in quotes. You have a match action pipeline where you say, I match on something in the packet that might be, for instance, in the Ethernet frame. I say, oh, right, this is an IPv4 packet, so I will treat it as an IPv4. I apply some logic on it. And this is on the ingress side, so when it's coming in. And then, well, where do we emit the packet? We don't know yet. It might be on one of the interfaces. We have to decide this. Then we again have the same type of match action pipeline on the right, on the egress side. And finally, before we send it out, so assuming we had an IPv4 packet coming in here, in our NAT64 case, would all go through here, it would be modified, matching on IPv4, translated to IPv6, made an IPv6 packet, and being sent out. That's generally always how P4 works. Right. So how does it work together with NAT64? Basically, the design is the same for both targets. It's really, really very similar. In general, in P4, the cool thing is you program the switch. So you have a P4 switch running NAT64, and you have the IPv6 and IPv4 hosts connected to the same switch. What P4 cannot do very well on its own is handling state. So if you have a new connection, you want to make a table entry within the fabric itself, you cannot really modify your tables. For this, you use a P4 controller. This can be connected via Unix socket in the software emulation case, or via TCP socket when you are on hardware. Right. In practice, I already mentioned a little bit, is there are some differences in the different P4 targets. The NET FPGA, for instance, doesn't support functions, which is, quite a basic thing in most programming languages, but you can work around this with defines. For the C programmers under us, it's like basic macros. So you can use a different approach, which gives you the same result. So when you look at how you do things without P4, you have, for instance, a network segment where you have IPv6 only hosts. This is a very typical thing. Then you have another segment where you have IPv4 only hosts. So it might be a legacy network. And then somewhere more in the edge or the outer part of your network, you actually have a router by default, which does the NAT64 translation. That's a classical case. In our case, it's very different, because with P4 being in the switch, you can connect any host to any switch, and the switch itself is already doing the translations. So you can simplify your design. You can actually decentralize and have the translations going on here. So instead of the packet going out of your network, going to a router, and going back, maybe into the same segment, you can do it right here without going much further and with very low latency, obviously. Right. Some things that are really, really different in IPv4 and IPv6 is that IPv4 has this nice protocol named ARP to find out which MAC address belongs to which computer. In IPv4, it's a separate protocol. In IPv6, it's a sub-protocol of ICMP6. So on one hand, in the IPv6 world, we have it unified inside the IPv6 protocol, but the whole protocol got a little bit more complicated. In the IPv4 world, it's a different, ARP is a different protocol, but it's a bit more simpler held. In the end, both do the same thing. However, and now comes the interesting part. In the IPv6 world, I said it's a sub type. You have the IPv6 protocol. You have the ICMP6 header. Then you say, okay, I'm actually a neighbor advertisement, so I advertise my MAC address to you. And the problem, and that is a bit funky in IPv6, and anybody who's doing stuff there, I want to warn you a little bit. IPv6 specifies that you have a number of option fields and this option field actually contains the MAC address in the end. The problem here is hardware doesn't do very well with variable length things. So if you have 4 or 5 different option fields, where do you stop parsing? And how do you parse this? The order can be arbitrary. So this is a bit tricky in the IPv6 world. In practice, like what I did, is in reality, you have the link layer option and you have the MAC address. So the order is usually fixed for reality. If you think about security, if you think about exploits, this is not a good assumption I made here. So this is a bit the drawback of a IPv6 packet design. Right, so let's have a look at an example. Let's say an IPv6 host sends a packet to 2001 DB8 cafe : 192.022. Fun fact, this is a valid IPv6 address, even though this is an IPv4 address. It's called IPv4 embedding. It's literally a valid IPv6 address. I just have to stress this very much because it looks funky, it is valid. So in the switch, we have a table entry that matches on the /96 network. And if you do the math, IPv6 has 128 bits. You use 32-bit of it. And with this, you get a /96 prefix, and that covers the whole IPv4 internet. So for me, it was really interesting to see like the whole IPv4 internet is such a tiny bit of the IPv6 internet prefix that I use here. What happens in the P4 world is that when this match is there on this prefix, we call an action and we see, all right, we want to map this to IPv4. So we add an IPv4 header, we map the IPv6 source address and destination address, and we replace the headers. And then in the end, the switch says, all right, we have to deparse it into an IPv4 packet, and we set the egress port where the packet goes out. This is literally how it works inside the switch. Right. The translation direction matters quite a lot because of the size. So size in this regard really matters. The IPv6 only host can address the whole IPv4 internet within this prefix. The whole IPv4 internet, not the subnetwork of your network, but the whole IPv4 internet. However, if an IPv4 only host wants to connect to an IPv6 only host, we need to cut off a little bit of the IPv4 space. This can be a private network, can be a public network, and map it then to an IPv6 address. But the problem here is because of this asymmetry, that the logic is a bit different from one to another way. But it also shows very well like how powerful IPv6 is and how limited IPv4 is. Then one of the big differences is whether or not you're implementing stateless or stateful NAT. Stateless NAT means you're usually doing one-to-one mappings. You can say you're, for instance, an IPv4 island in your network, and you want to expose and make all hosts of this IPv4 island accessible via IPv6. This is very easy. You don't need to do anything session-based. You just add this table entry and you're done. On the other hand, if you have an IPv6 only network and you want to hide it behind one IPv4 address, this is what is usually being done in the IPv4 world with CGNAT, where you want to hide a lot of devices between one public IPv4 address. For this, you need sessions because you need to map the ports. If you have TCP, if you have UDP, you need to map the ports in the table of the switch. And what I mentioned before, the switch here itself is unable to do that. So for this, we need an external, we call it a P4 controller. We see here that there's no table entry for a new, let's say an IPv6 only host wants to talk to the IPv4 internet. We don't have a table entry here. It sends it to the controller. The controller creates a table entry in the switch here and re-injects the packet into the switch, which then in the second run sees, oh, there's a table match for this specific session. And we will translate it, deparse it, and output it as an IPv4 packet. It might sound a bit, let's say, too deep in here, but the point is stateless is very, very easy. So if you have, in general, such a mapping in your network, it's a very easy thing to handle. Stateful is always a bit of a problem, or a problem. It's more effort. So when we move on from one protocol to another, we have to change the payload. We have to change the checksum, sorry. The problem is the hardware here, the NAT FPGA card doesn't support building checksums over the payload. However, TCP and UDP have checksums over the payload. So this was a major showstopper here in the beginning. And what you can do is you can actually calculate the differences between the IPv4 header checksum, which is in the end it's a number, the IPv6 header checksum, and diff those two, because you don't have the individual checksums that you can calculate. You have to build the difference and use this as an offset. As an example, for a UDP translation, we have the checksum over the v4 source address, the v4 destination address, the total length -20, and the protocol. In the v6 sum, we have the IPv6 source and destination address, the payload length, this is plus minus the same over here, and the next header. So the checksum we can calculate with the original checksum plus the IPv4 checksum minus the v6 checksum gives us the new checksum. Looks a bit complicated, but it works. The actual code looks like this. Basically, we initialize here with 0, and then we fill up the v6 sum, the v4 sum, and then we build the delta between those two. So it looks a bit more complicated than above, but it's the same code in the end. So what are the results? Are we having high-speed NAT64 or are we not? And now it gets really interesting, because I was actually comparing with software implementations. So the NAT64 benchmarks that I made, I'm sorry for that. I compared with Tiger, with YOL, and the hardware implementation. Tiger is a user space implementation, and there I was able to measure around 2 to 3 gigabit per second. With YOL, which is a Linux kernel module, I was able to sustain around 7 to 8 gigabit per second. And this is quite impressive for software translation. With the NAT FPGA, I was able to almost satisfy the line speed around 9.29 gigabit per second. All of them is measurements I've done multiple times, around 190 seconds. So P4 really is going to line speed. We're really, really near the 10 gig possibility there. And the interesting part is, so NAT64, once you implement it for one target, it is quite easy to implement it on a second target. However, what is really, really surprising, as I said, YOL, the kernel module, is really surprisingly fast. I'm in touch with the developer there, with the author. I think was originally developed by Nick in Mexico. And I'm not sure if YOL will scale up to 100 gigabit, 400 gigabit, or terabit. This is something that needs to be found out. The P4 code, on the other hand, is written in a way that it can easily be just recompiled on a 100 gigabit interface, and it should just work. On the other hand, I also have to say the NAT FPGA platform that I was using wasn't fully reliable. So sometimes the network card would actually crash, usually around 2 or 3 hours of sustained traffic. So there is probably some kind of memory leak within the compiler or the output of the bitstream on the network card. I haven't been fully able to find out the origin there, but it's something to be aware of. The NAT FPGA specifically might not be the most or best platform here. There are a lot of other P4 targets as well. Then P4 itself, it's a very interesting programming language, and I can really recommend diving into it. But it's also a young programming language. You kind of miss some things, like when you have programming languages and you have a lot of modules to combine things, the framework itself is not yet there that you can like repackage and redistribute easily. But that's just a matter of time from my point of view. That's it from my side. I hope you enjoyed it. So in theory, you can apply NAT64 easily now on line speed, 100, 400 terabits should all be possible. If you want to give it a try, just contact me. I'm available on the IPv6 chat. You can reach me by email on ipv6@ungleich.ch. I'm also on Matrix and Twitter. Yeah, thanks again for having me. It was a lot of fun being here with you, and I'm looking forward to any questions if you have any.
Yes, many thanks, Nico. So I don't know if there's anybody has any questions. I'm just checking. Alex, is there anything in the Q&A? Okay, I don't see anything. Hopefully I haven't missed something. We have to flip between different screens to find all of the information, but I think everybody's happy with what you've told them, I guess.
Good.
So, thank you very much for that.
Thanks for having me.
We shall move to the next presentation, if we can.
Thanks a lot. Wish you a lot of fun. See you around.
Thank you. So the next presentation is going to be given by Sergey Valov. He is the CTO and co-founder of IPv17, sorry, not 16. He's going to be talking about the UDTP transport protocols and some of the results around that. So I'm going to hand this over to you now, Sergey.
Very well. Can you see me? Good afternoon, dear colleagues. My name is Sergey Valov, and today I wanted to share with you the results of the work that we have been engaged in for the past several months. Transport Protocol UDTP, why this name? This is a protocol that can work in various directions. It's a reversible protocol. One of the key problems today, that the higher the latency, the higher the loss, then the lower is the speed of transfer. And there are many people trying to solve this problem. Some achievements have already been made. One of the possible solutions to this challenge is our protocol, and I wanted to talk today about our results and about this protocol. Now, what is the main issue? The way we understand it is that the packet itself is the issue, is the fundamental issue. And then there is also asynchronous transmission, which is, on the one hand, its main advantage. On the other hand, it is the fundamental flaw. The problem is that the transmission of a packet in the network leads to unknown, uncertain latency. And those delays, they are varying. There is a jitter in those delays. And since different traffic passes through the same queues, there is a correlation between traffic and this causes a traffic interference. As to what kind of traffic is going through the network at the moment, sometimes it's not possible to identify that traffic, and sometimes there is even a mistake in identification of the type of traffic. There is also a need for some external management. We need to have a harmonized management system to handle queues accurately. When the packets pass through networks of different operators, we need to have an aligned policy on traffic management. In order to deal with these issues, we offer the UDTP protocol. We believe that UDTP is capable of handling those problems. And now let's turn to the mechanics of this protocol. It is an independent component. It can travel via UDP to go through NATs and firewalls. And we're using the port 3000 today. It can also work over IPv4 and over IPv6 and also IPv10. And we use an experimental number of this protocol, 250. We tested it over Ethernet. We tested it over VLAN. And we are using a different variety of this protocol, 8000. The protocol has functions that are capable of correcting errors. What are we doing differently? We decided, again, that we need to start with a packet. We call it packet 20. The packet, when we establish a connection, we tell immediately what is the speed, what is the throughout speed of the transition that we expect, that we would like to see. And we do not use methods to improve the performance of the protocol. We do not use deduplication. We do not use compression there in this protocol. We do not use multiple patching. The current version of the protocol is version 1.0. The protocol is registered in the system as a peer protocol to UDP and TCP. It's the same tier protocol. So socket API, and this is how we did it. In order to use the protocol, the developers can state the UDP number 250, open the standard socket by establishing the number of the protocol, and also we need to define the bitrate. And after that, the protocol will be running at the required bitrate between endpoints. A couple of words on the headers. We use two types of headers. They're all of the same type of size, 24 bytes. The first header establishes the connection. It does the handshake. And the handshake uses the zero trust principle. So we establish a connection with the other party, and the time when the connection is established, we verify the bona fides of this subscriber. We also say which higher level protocol we're going to use. We establish the bitrate, and after that we start transmitting data. And I need to mention here that we do not use port numbers. We don't have that. And as soon as the connection is established, the global label is generated. And for us, global label is the substantiation. And after that, the app will not be able to change the bitrate and other parameters. It will continue running at the same speed. When we are transmitting data, we also define the type of traffic that is used in this session. We can say that it's a file, say it's a certain type or size of data, or it can be a flow, a particular speed but no size, or we can say it's a message, a small message as part of the packet. We have the number and the timestamp of this message, or it can be a command. And the command will be used instead of the border. And this is something that is used often in robotics. And we also use the packet number to pass existing traffic. When establishing the bitrate, when filling out the bitrate field, when we say that many bytes per that much time, we can say that we are transmitting a certain number of bytes per hour, and every 25th second of every hour, that many bytes should be transmitted. We can say that all the 20th second of the 15th hour of a particular day, the data must be transmitted. This configuration of bitrate is very useful in IoT when you are querying devices. And the protocol will assume this function and perform this function. The bitrate field itself is quite extensive. It's big enough to transmit data at current, at modern day speeds, reasonable speeds. What are our objectives with this protocol? Well, we would like every network app to get an allocated bandwidth, because the protocol can also guarantee a particular latency, and it can normalize latency fluctuation, that is to say jitter. Today, IP networks do not enable, well, they do, but it's a challenge to achieve all these goals at once. One other objective that we have is to prevent interference of traffic. We want to make sure that there are no critical latencies to the traffic. And in one link, we'll be able to combine traffic in real time and non-critical or traffic that's not critical in terms of real time. We will be able to prioritize different types of traffic so that real-time traffic gets ahead without any delay. And since the protocol is on the endpoints, external management of queues or policies is not required, because endpoints and systems will agree between themselves on their own as to what is supposed to happen. Today, the first version of the protocol is ready, and it is already running on Linux. Later, we will show you the results. But let me dwell a little bit on comparative characteristics of different transport protocols. Here you can see 5 key protocols that are widely used in the internet, and you can see the differences between them. One of them is handshake. We use a slightly different type of a handshake. All protocols, of course, use a connection, is the basic function. Connection ID, we use a 64-bit global label. Data transmission is byte-oriented. There are multiple streams that we can organize. And let me explain why we believe that the protocol is not going to lose speed and why there won't be any delays. we do not have the transmission window anymore. It's not window-based. We have a credit-based mechanism. This is what's implemented today in the protocol, but in the future, right now we see that it has some deficiencies. In the future, we plan to switch to predict-based mechanism of data flow control. We use CRC32 for loss detection. We use internal inbuilt security, and we have a separate mechanism which we called packet chain. We are building a chain of packets. They are all interlinked. When a packet is dropped or when a packet is distorted, the chain doesn't break. But if the packet is modified or a different packet is inserted, the chain is broken. And we will see that there is a substitution of traffic happening. And there is some kind of hijacking going on. And this will allow us to protect against DDoS attacks. Not fully, though. We believe that we'll be able to do it completely with the next version of the protocol. The endpoint will not come under attack with DDoS attack because all packets will be processed. And only those that are fully processed will be going outside. So it wouldn't be possible to simply block the service. And last thing, as I have already explained, the size of the header is fixed. It's 24 bytes. Today, we have drivers for Linux kernel 3.0 to 5.4. We tested it with different distributives. 32-bit and 64-bit x86s and ARMs as well. These are the supported architectures. We also tested it on Elbrus. We have 4 applications that we are ready to demonstrate. There is file transfer, which is an analog for FTP or SCP. We also developed a proxy that integrates existing services and that translates transmission into our protocol. There is also a tunnel that unites different services in local networks. And there is a test program that uses iPerf3 for experimenting and testing. What are we aiming at? We want to be able to operate at the speed of the interface, be it, I don't know, 10 gigabit or above. If it's a higher speed, we need, or we will need, a hardware support, and we are working on it right now. What do we want to achieve? If there's time given, we want to be able, within this given period of time, to service more clients, or to become more responsive with higher speed for a particular client. And we also want to be able to resist better cyber attacks. What are the testing results? We have a pilot sandbox. We have 4 virtual machines. They are all typical. 1 gigabyte of memory, 10 gigabyte of hard drive memory. We install those machines in Moscow, Amsterdam, Sydney, and Santa Clara, and we tested file transfer between these virtual machines. Moscow to Santa Clara, when there was this transfer, we used SCP protocol, which shows it, not because it has crypto protection, crypto security, but because it demonstrates better performance than FCP. Moscow to Santa Clara latency was 194 milliseconds, and average SCP TCP IP stack transfer is about 10 megabyte per second. With our protocol, we achieved 111 megabit per second. Moscow to Amsterdam latency 46 milliseconds. Obviously, speeds were higher. We recorded about 40 megabyte, while with our protocol, we recorded 115 megabytes. You can see, although the latency difference is almost 4-fold, still we had basically the same speed value. Moscow to Sydney latency 313 milliseconds. The SCP TCP IP gave a speed of 2 megabytes per second. With our protocol, it was slightly below 100 megabit per second. So we were not able to maintain the speed within a narrower range, but still it's pretty high. Our colleagues, they did another test, and they installed their own test zone, deployed a test zone, and you can see here the losses that they used, and you can also see the values of the latency. The maximum latency was 200 milliseconds, minimal was 2 milliseconds with 0 loss rate. The speed without protocol was 92.35%. They compared us against TCP with different control methods in place, BVR and cubic. These were their parameters. Another test, they say that this is typical for an LTE network, 44 milliseconds, and the latency was varying between 80 and 40 milliseconds. Our utilization was the same 92%. And the last thing they emulated was a satellite channel with a delay of 204 milliseconds, maximum delay of 600 milliseconds. And again, at a 0 loss rate, it's 92% again. So regardless of the latency, be it 2 milliseconds or 600 milliseconds, our performance was the same. You can also compare this with TCP performance. You can see the difference in the bandwidth usage, and you can see that it's quite impressive. We have already agreed with Rostelecom to use the radio lab that they opened in St. Petersburg at the Bobruyevich University, that we will do jointly a much more comprehensive test of our protocol. We will compare it not only with TCP, but we'll compare it with Quick, SCP, and other UDP-based protocol. What are the results that we recorded? UDP protocols, it works in the existing network, IPv4 and IPv6 alike. It's not blocked by internet infrastructure, and the protocol really increases the transmission rate. In our plans, well, we plan to extend it to all well-known architectures, and we also want to extend it to other OSs. Here you can see the Linux kernels 3.4.5. We plan to develop drivers for Windows, for server platforms, and for desktops. We also have plans to continue writing for Android, macOS, iOS, and real-time systems. Real-time operating systems. This is the plan of the program of work. We tested Usenet in distributed file systems. We tested it in block systems, DRPT. There was a test for a database integration. There was another test for web servers. We already did integration to transmit video streaming, video conferences, and we see that there are many more applications for this protocol. There are at least 12 possible areas of application. We believe that data centers synchronization speeds can be really improved. The same applies to distributed data storage systems, data centers. It can be applied in robotics, in automatic control of transport. The protocol itself is developed as a versatile protocol with an extremely wide area of application. And in the end, I will be very happy to hear your comments. And if you have, if you think that this might be applicable to you, if you have a distributed system and you would like to test our protocol in your environment, we will be more than happy to cooperate. We are open to all kinds of joint projects. And I'm done.
Okay, thank you very much, Sergey. I see there are a number of people in the queue. It looks like Dmitry is first. So I'm just giving you the floor, Dmitry.
Hello, I hope you can hear me. Yeah, we can hear you. I was very curious to find out about your work, and I would also be, do you have a document, a draft, something? Of course, I will be studying your presentation later, but do you have any detailed descriptions? And what about the compatibility of your protocol with IPv6? This is the second question. Okay, thank you very much. The specification as an RFC is not yet prepared. We didn't do it. We have colleagues in Silicon Valley, and they suggested that they would draft an RFC, but we decided to park this question for now. We have a detailed specification, though, which can be transformed into an RFC, but we have not been doing this. We decided to first solve our technical issues because they are still plentiful. As to compatibility with IPv6, as I have already mentioned, it runs everywhere, IPv4 and IPv6.
Okay. Okay, there's another.
I don't know if I've answered your question.
Okay, we'll go to the other Sergey, another Sergey. So, Sergey, I believe you should have the floor.
Hello, and thank you very much for the presentation. I don't have a question. I have a comment or a suggestion. I think that you need to start a discussion at IETF, and of course you wouldn't be coming with an RFC. You will start with a draft, and if you have like if you organize a broader discussion, things might change before. Can you open page 10, please? Because I have something to ask on that page. But I'm just thinking that if you start a discussion in IETF, at IETF, you might have changes in your protocol. Your slide says that your protocol is unique, like in packet chain, but it's not. Well, packet chain, as I have already explained, it's not just one session, one connection. Even if you close one session, you open a second session from the same or at the same endpoint, you resume at the place where you left off in the previous session. So in our case, packet chain means an end-to-end chain during any communication between the endpoints, even if you have one or two or a million connections. TCP does this within one connection, not multiple connections. Do you have anything on GitHub? I'd like to see the code. This is what I'm asking. Is it possible to get it anywhere? Yeah, we were thinking about publishing at GitHub, but since we need to pay back the money that we've been investing for the last 4 years, until now this development has been a private one. Well, later we believe that later it will become an open source development, but we can't afford going open source now. It's too early.
Okay, let's move on to.
But if you need it for your projects, for your purposes, I'm sure that we can find a solution. The code is not very long. It's about 5,000 lines. It's C-based, and we did it ourselves from scratch.
Okay, let's move to the next question. This is from Toma. So you should have the floor.
This is Toma Gavrichenko. I have 2 questions. Did you test the numbers that you showed on the slide with respect to resilience and speed? Have you tested these numbers, these values, at some independent labs, professional labs? Yes, one of them is our Chinese partners. They did their own testing. Okay, which ones? What was the lab? No, I'm under an NDA. I'm sorry. This is what I mean when I say independent. Independent are the ones that are ready and willing to go public. Well, we have Chinese partners, and they did their testing, and they shared with us the results that I shared with you today. As to independent, we plan to engage Rostelecom. They have this new R&D center. They have their new labs in St. Pete, and we want them to publish all the results together with the methodology after the testing. Can you go back to page 4? I think it was page 4. I may be mistaken though. Yep, this one. So I have a question. IPv10, you say. As far as I know, Pretamar, the author, patented this protocol, and he's suing, or he plans to sue everyone who is using that protocol. Have you talked to your legal department about this? Well, we included the reference to this protocol here so that we do not forget to test our protocol for compatibility with this protocol. But when we read about all this litigation, then yeah, we decided against it, and this is my mistake. It's you can say it's a typo. I should remove this from the presentation. Yes.
Okay, there is just time for one more question. I just want to check with Alex whether there's anything in the Q&A. I didn't see anything, but okay, let me go to Dmitry again.
Yeah, so we have a couple of questions
okay.
In the Q&A. Yep.
Alex, yeah. Alex, if you want to read those.
Okay, 2 questions. One. Island 250, port 300. All registered, 8016-bit. So code point hijack is one question, and the second question is ABR at the time of ATM worked, but it was based on cooperation of all intermediaries. How do you plan to organize signaling in mid-plane? Okay, first question. With respect to the protocol numbering, in terms of IP 250, in the RFC, there are experimental numbers. If I'm not mistaken, it's between 250 and 255. It's one number of this range. So if this one has already been assigned to somebody else, then of course we will use a different number from this experimental range. In Linux, the last number in this field is 142. And 143 is considered to be the last not taken number. As to the port 3000, everywhere we used it for transmission between private closed networks. It was free, it was open. But if we indeed see that it's taken, then it's not a matter of principle. We will do something, we'll find another port. When we are ready to file for the isotype number, the organization will give us the valid number. And what was the second question? Can you repeat it, please? There was something ATM and I'm sorry, I'm not sure I understood the question, the second question. ATM and packet networks, what do you mean? Okay, I'm reading the question as it is written here. APR, at the time of ATM, that discipline, it worked. This is what you are suggesting. The bandwidth control. But it was based on cooperation between intermediaries. In the general case, it does not exist in the packet networks. How do you plan to organize signaling? Okay, I think I understand now. Okay, let me switch this. We use credit-based speed management, speed control. Traffic that comes to the end system is evaluated, and we assess its ingress speed. In terms of speed of transmission, during 1 second, we know that there is this number of packets that we must receive, and the pool must be filled to a particular volume. And when this volume is not filled, we will understand that there is a delay, and this delay is caused in the network by some reason. Or, on the other hand, it can be overflowing. There may be an overfilling. We have signaling between endpoints that we use to send a signal of either accelerating or decelerating so that the volume of incoming data matches the bitrate, the speed that we define in the beginning. This mechanism is prone to delays. There is a circular delay, or for the RTT, that's to say, not circular, but to and back delay. So it works, this mechanism works, but it doesn't work perfectly, and that's why we are going to move from credit-based to predict-based mechanism of speed control. We want to be able to predict the speed, and we need, for this, we need the endpoints to negotiate this between themselves. And no policies will then be involved. It will be an end-to-end communication negotiation thing.
Okay, I appreciate that we're over time a little bit, but we did have a little bit of a delay because of the interpretation problem. So actually, well, there was another, there was a question in the queue, but I think that's actually disappeared now, so maybe we're okay. So I think in that case, I'll draw this particular session to a close, and many thanks to Sergey for your presentation, and actually I think it definitely stimulated some questions for sure. So thank you, and thank you to the previous presenter as well. I'd just like to remind you that the next session starts at 15:30 UTC +1, and this is going to be the round table about the telecoms in a time of a pandemic. So that's going to be pretty interesting, I think. So we will take a short break, 25 minutes, and we will see you back, 15:30 UTC +1. If you're not in this particular time zone, which probably many of you are not, as it's the Amsterdam zone, but in about 25 minutes.
And there is also Kahoot. There is a Kahoot session coming up. It's a lot of fun. Come and join.
Good afternoon, everyone. Welcome to the Kahoot quiz. My name is Terence Cherba, and I will be your host today. So you know the drill, and I can see people are already including their registration number. So please go to your mobile phone so that you can actually see the questions. And there, either go to your app, to the Kahoot app, or go to kahoot.it. And please type in the game PIN number, which you see here, 530230. And if you include your registration number, then we'll have an easy task sending the prize to you. So you really want to include your registration number. And today's quiz will be about DNS. And of course, you know everything about DNS, so it should be quite easy. And today is the last quiz, of course, the last day of the meeting. And once we are done, you're going to get your prizes. So please remember, you don't only have to be good, but you also have to be fast. Excuse me. So if you answer the question, when you answer the question, make sure you are really fast, because otherwise you might lose points. We're almost there. I'll wait for a little bit, few more participants, and then we can test our knowledge on DNS in a few seconds. 12 people. 12 people. So let's see. I'll wait for a few, let's say for another minute. One more, 13. Today is Friday the 13th. So we have 13 participants. Let's get another one. So we're almost ready to start. And remember, don't only be quick, be good as well. We're almost there. One more person. Otherwise, we start. Oh, yeah, 14. Very good. So let's get started. Get ready. DNS. 3, 2, 1. Quiz. What does DNS stand for? Distributed naming system, naming service, domain name system, deoxyribonucleic solution, or domain number system. What's the correct answer? Well done. Everyone got it right. Of course, it's domain name system. Next one. Oh, and Sergei is in the lead. Well done. Let's continue. Second question. You have to explain DNS to your grandmother, babushka. What do you tell her? DNS is the gossip group of the internet, the telephone book of the internet, the calendar of the internet, the criminal record book of the internet. Which one is it? Well done. Almost everyone got it right. Of course, you tell your grandmother it is the telephone book of the internet. And, ooh, Menoska is now in the lead. Well done. Let's move on. Third question. Which file contains the DNS records on the DNS server? Is it the host record file, the record file, the domain file, or the zone file? Very good. Almost everyone got it right. It's the zone file. Next. And now we still have Menoska in the lead. Well done, Menoska. Question 4, what does TLD stand for? Is it top-level delegation, top-level domain, top-layer domain, or is it tensor-level delegation? Everyone got it right, of course. I see that the questions are a little bit too easy, so perhaps we should have gotten some more difficult questions. But anyway, let's move on. And we see that Menoska is still in the lead. Let's continue. Fifth question, what is DNS reverse resolution? Is it the mapping of prefixes to AS numbers? Is it the mapping of resource records to the right database? Is it the mapping of IP addresses to domain names? Or is it the mapping of domain names to IP addresses? And again, almost everyone got it right. Of course, it's the mapping of IP addresses to domain names. That's reverse resolution. Menoska is still leading, Sergei is second, and QWSX is the third one. Moving on, question 6. What is the top-level domain for IPv6 reverse delegation? Is it IPv6.ARPA? Is it IP6.ARPA? Is it INET6num.ARPA? Or is it INADER6.ARPA? What's the correct answer? Who knows this? Probably all of you. Wow, okay. It's IP6 ARPA. So remember, there is no V in it. And why is it IP6 ARPA, not IPv6 ARPA? In Hungarian, we say it's to confuse the enemy. And you can see some of us are now confused. So the correct answer was IP6 ARPA. Let's move on. Sergey got the lead back again. Konstantin 16 is the second one, and Lex 282 is the third one. Well done. Moving on. Seventh question. What is SOA? Is it standard of domain names? Is it something Dutch people don't want to get? Is it the start of authority record? Or is it the system of allocation of domain names? And it is indeed the start of authority record. Well done. And Sergey is still in the lead, and Lex and Konstantin traded places, but they are still second and third. Well done, everyone. Moving on to the eighth question. Individual DNS records are not signed in DNSSEC. What is signed instead? This is perhaps a bit more difficult. So is it the record set? Is it the entire zone file that is signed? Is it the SOA that is signed? Or is it each line in the zone file separately that is signed? What's the correct answer? And I knew this would be more difficult, of course, because we are talking about DNSSEC, but it is the record sets that are signed. So, for example, the A record set or so on. And it's not the entire zone file because the record sets are signed separately, not the entire zone file is signed in DNSSEC. Moving on. And now AI, I assume that's artificial intelligence, 281 is in the lead, well done. CGR is the second, and Sergey N is the third one. Very good, quite exciting. And now the ninth question. How can you know which is the most recent version of the zone file? Is it by the serial number? Is it by the version number? Is it by the age timestamp? Or is it by the age number? And indeed, it is by the serial number. So yeah, that is important. And finally, so now we have AI 281 in the lead, CGR second, and Sergey N is the third one. So let's see who will have the lead in after the final question. So get ready for the final question. And the question is, you need DNS because people are useless at counting in hexadecimals, remembering numbers, being nice to each other, or remembering domain names. What is the answer? Indeed, it is because people are useless at remembering numbers. Of course, people are very good at being nice to each other, as we know. So let's see what is the final situation. DNS podium. The bronze medal, third one, goes to CGR. Congratulations. Silver goes to Sergey M. And the first one, the winner is AI 281. And you will all get your prizes. And the runners-ups are Konstantin and Symbol. And you'll get all your prizes. We'll send it to you. You're getting a t-shirt. And thank you for participating. Goodbye and see you next time. Take care. Bye-bye.
Okay, so welcome back to the final session of ENOG 17. So we have just the one item for this session, and this is the round table on telecoms in a time of pandemic. So I think this is going to be hosted by Alex, and I think Alex, is this over to you now?
Hello. Yep, I'm here. Do you see me?
We can, yes.
Thank you.
As far as I understand, we're going to have several participants. Alexei is going to be the moderator or not? Alexei?
Yeah. Да, я здесь.
Yeah, I'm here.
Yeah. Okay. We see you, Dmitry, Tama, Pavel.
Alexei, are you okay?
Yeah, I'm okay. I'm okay. I'm here. Okay. Let's start. Здравствуйте.
Hello.
Здравствуйте. Yeah.
А уйдите, пожалуйста, с этого канала. Это английский канал.
Ага.
И тогда вы не будете меня слышать.
Да. Как уйти?
Внизу в основном интерфейсе два флажка, английский и русский. Там нужно выбрать русский.
Я не могу на него. Сейчас. Он говорит, что нужно остановить запись. Прежде чем уйти.
Или говорить по-английски в этом канале.
Я понимаю, мне не дает уйти. Он говорит, что стоп. Все, понятно.
Так, hello once again. I'm sorry for this technical disruption. Hello everyone, and this is the round table. We are going to discuss telecom in the times of the pandemic. My name is Alexei Chekin. I'm going to be moderating this session. We all live in interesting times, and it has been already half a year that we've been seeing each other online, and many people, I think, are already sick and tired of this virtual format. However, we have seen many changes, and we experienced many changes in the network too. From the start of the year, various research is published on what has changed in the network and where to, what's been happening to traffic and to Zoom capitalization. Zoom market cap has been fluctuating too, and this is something that we intended to discuss with our experts today. First, I want to start with a plot from Pornhub. And here is the screen. Yep. So this is Pornhub statistics. Not only does it publish wonderful videos, but quite often they publish also research studies on the viewings of those videos. And you can see that from the start of the pandemic, over here you can see the total increase in global traffic, which is on average 10 to 20%. But if you look into the details, in some countries, especially after Pornhub offered a free of charge premium account to those viewers, their traffic surged to 50 or 60%. Or you can look also at the y-axis plots. Top left plot comes from the Italian IX, then AM6 and DECIX. And everywhere we observe a material increase in traffic when people went into a lockdown. But on the other hand, there is also the Swedish IX, and they didn't see much change there. So today, with our wonderful experts, I wanted to discuss what changed for them and how they managed to live through this incredible year. Today with us, we have Dmitry Lopata over here. Hi, Commercial Director of REPA. Timo Gavrilchenkov, CTO of Curator Labs. Pavel Zavyalov, Business Development Director of DataLine. And Maxim Tulyev, Director of NetAssist. So, colleagues, I suggest that we take turns and we all answer the following question. What changed for you in the last year? First, you can give me a very general answer. Well, the year is almost over. It's coming to an end. We've been confined during the last 8 months. Did anything change in your business? Who wants to start? I can start. I even have 1.5 slides on the topic, if you would allow me to share my screen. So that I can let other people to look at my slides, you need to remove yours. I understand it's pretty, but okay. Here it comes. I need to give you a warning. I have just realized, well, I saw, Alexei, that you started the session speaking into the English channel, and I thought that you would be speaking English yourself, and that's why I immediately opened my slides and started translating them into English. So you will notice that they will be presented in several different languages. Anyway, as the industry, we looked at different traffic exchanges to analyze the growth factors. We will discuss the variability across countries maybe at some point in this conversation, but this is statistics, and in this table there is a mistake. Actually, this is not traffic. You can tell that there is no gaming here. These are only HTTPS services. And this is the number of HTTPS queries. Because traffic was totally, it was up and down, upside down. There was no compression. There was, many services started expanding, scaling up. Without much technical preparation, and that's why traffic values, I don't think that they are very indicative. Anyway, to go back to this slide. And by the way, gaming, why I understand that this is a digression again, but why gaming is important. In March and in April, you could see several times a real surge of traffic because Call of Duty, Call of Warfare came out. And this is a typical example that in the pandemic, people are trying to keep themselves busy. They are trying to entertain themselves, and new games are being released with a lot of junk on the sides because you have to strike your iron while it's hot. And DDoS attacks, those attackers, they too were not sitting idle. They were attacking educational resources and e-commerce resources primarily. And probably this also shows you what people were happy about and what they didn't like. And maybe I should stop here and just ask another speaker to take it from me. I will be the one to take it from you. There isn't much that I can add, but yeah. Call of Duty meant an extra 5 or 6 hard working days for all of us to sustain that traffic. In March and April, there were peaks in traffic, then there was some quiet period, and then traffic started growing again in the fall. We don't have the numbers yet, but about the average growth rate will be 22–25%. And all these peaks associated with releases of operating systems or games, this imposed really additional obligations on us. So we had to expand all our capabilities. So I can only confirm what other colleagues have already showed and said. Maxim? Yeah, can I? Well, we're all familiar with all these diagrams and graphs and curves, and we all know how traffic has been growing. There is something that probably didn't come to the attention of everybody. There is something critical for the industry. We noticed that at the start of the quarantine, we saw a tremendous increase in the home users numbers, which was good, but then we started investigating, and what we found out was in every apartment building now, 10% of people do not have fixed connections or cable connections to the internet. Why? Because they are satisfied with mobile internet. It's enough for them. They have internet at work. They have never been using, well, or rather, they haven't used much of regular steady internet connection at home. Do you remember the times when people started disconnecting fixed line phones? Today, only few people, at least in our country, in the Ukraine, have fixed phone lines at home. We need to understand what to do about it. We all understand that to work at home all of the time and to watch videos, mobile internet is not enough, and as soon as they realized that, they went to subscribe to new connections. 5G and even 4G really, and lower prices. And by the way, mobile operators are aware of the fact, and they responded, and they started reducing gigabyte prices. They can't, go to zero in 3G or 4G networks because otherwise they will lose their ranges. But prices are declining, and this fall may be quite dramatic. What was happening when 3G came to replace 2G. Another thing that I noticed is that we have problems with Bluetooth-based wireless headsets, which are totally not capable of ensuring dual communication when we are listening and speaking at the same time of the quality that would enable normal communication in a meeting. If I were wearing a Bluetooth headset now, I would have been receiving awful sound. One-way communication, like music, it's working fine, but I managed only to find one headset by DECT, but it is very expensive, very expensive. So another strategic aspect that urgently requires a solution is normal wireless headset for speaking and listening with highest quality at the same time. Thank you. I think it is my turn now. Can you hear me? For us, the lockdown resulted in the split of the company, really. People who are administering the network and the operating systems, actually, we found out that they can all be sent home. We went home in March and we never got back together again. But the data center is a non-stop production facility where you need people, whether you like it or not. So that's why our production part stayed at work. They stayed in the office, basically. And it meant for them face masks and gloves and disinfection and reducing the number of customers at the site. And they had a lot of work. You must understand that we have about 5,000 customer racks at data line, and every day there is some maintenance, scheduled maintenance, non-scheduled maintenance. So we had really to rethink our all of our arrangements there. In terms of customer services, for many years we have been promoting remote workstations and all kinds of video technologies. And as soon as this madhouse opened its doors, big customer installations of VDIs felt like a snowstorm, and everybody wanted to get a test immediately. They all found themselves suddenly away from their offices, and it's clear that as soon as as soon as people are all working from home, security becomes an even more relevant issue than it was in the office. So again, we started selling more remote workstations and everything that's related to IT security, and we saw an incredible increase in those sales. Alexei, I think that you are either not speaking into the right channel or your microphone is off. Either or. Yeah, I switched off my mic. Yes, Pasha, thank you. Actually, you started answering a question that I wanted to raise a bit later, but I have a question to Toma. Toma, Curator Labs, what about your customers? Did their needs change? Is there now anything different in terms of what drives customers to you? Well, actually, we saw more customers coming from particular industries like education. We didn't have that many customers in education before. In terms of the customer needs and the needs profile, no, it didn't change much. During the pandemic, there was no radical change in the format of the required products. We just started getting more requests. More requests coming from where? Education, you said. What else? Yeah, well, education and e-commerce and all kinds of websites. I noticed that, for instance, traffic went up to the sites that are associated with a religion. I don't know how to call it best, but this increase in traffic was similar for education and religion. If I remember correctly, in Europe, the churches, the religious services were not available in spring. It was happening everywhere, and also payment systems, all kinds of payment systems. if I don't know, betting, like sporting bets or Forex, they were among the top industries for whom it was, the threats were prominent. But since there were no sports in spring, apart from Belarus, only in Belarus people kept playing soccer, football. But all these attacks and ransom kind of attacks and attempts to manipulate betting, for instance. This is something that we observed. What about uplinks? Are you getting traffic cheaper now, or do you have any problems with capacity? It's a good question. We have a limited number of uplinks. There's just one operator, CenturyLink, that we use to look outside, and not much traffic is going in this direction. So we expanded, but it was easy, to tell you the truth. It didn't take much time. We scaled out just to be prepared for the future. It was more difficult to scale up PNIs that are distributed in the network with a lot of private interconnects and European operators, because not everybody were ready to upgrade themselves fast. Not everybody had the hardware, and this crisis affected everybody because Europe was also shut down for a while, and the equipment, the hardware, was either in warehouses, and well, there was no way to install it in the data centers. It was not just, it wasn't possible. As to prices, I think it's standard. There is a lot of pressure on the market. The competition is on the rise. The prices are falling. Same old story. Probably in spring and in the summer, people were a bit more restrained. They were cautious. They didn't know how things would be developing, but now we have a better understanding, a bit less uncertainty. We understand that this is a prolonged crisis, and probably we'll see a high competition and price wars in the market. I wanted to mention a couple more things. This year, we discovered cloud gaming, which is a major source of traffic. People started to buy accounts in all kinds of cloud gaming services, and people started playing. 30-35 megabit per user during a live stream, during a live game. Quite a sizable flow. And probably that's why we'll all have to expand our networks. Okay, Maxim, same question to you. Did something change for your peers and uplinks and traffic providers? Oh, I confirmed that we had problems with PNIs and with equipment. We are deploying a new node in Sofia at the moment, and not everything gets there on time, and sometimes there is a delay of a month, and we don't treat this as something unusual. Traffic is growing, but this is growth that should have been expected. We have links, those prices are flat. Traffic is up. We had to do several upgrades. It is said that those upgrades are not compensated in any way by the users. It's all our budget. It's not like the users started paying more. And this is actually important. There are low margins in this market. They have always been low. Okay, got it. A question from Q&A. Ukrainian mobile operators, do you provide cable access? Because in Russia, MTS and others, they are providing both a SIM card and a cable. Yes, we do, they do. Kyivstar is probably the best known case. They fight and they often win. They come out as a winner in the number of users of the cable connections. Sometimes they would provide us connection free of charge. Other operators are also trying to enter the market, like Intertelecom and MTS and Live. I'd say that they have like pilot projects. It looks like more test zones than real operational production facilities. So, but yes, the market is there and it's developing, and sometimes you see dumping of prices. Do you have any problems with VPNs? VPN services were growing at the same pace. It was the same percentage. It was the same growth rate, at least for us. Question to Pavel then. Did you notice any changes on the part of regulators? As far as I understand, Deadline is one of the bigger hosts, and some of your projects, I mean, the ones that you are hosting, are quite gigantic. What about the regulator or the supervisor? Did they treat you differently? Well, we are also a telecom operator. We are not just a data center. So yeah, we are subject to all this regulation. And I don't want to discuss that because XML, NetFlow, SNMP, it happens. But I think it happens everywhere and to everyone. So we'll have to comply. If you are subject to Russian regulators, you know this anyway. But those of you who are not subject to Russian regulation, probably you are not even interested. You don't want to know. When you say that we have big projects, we're hosting big projects. It's not just us. It's just that in Russian experience, you wouldn't find a single major project who would be sharing or contracting a provider for telecom services. Usually they would run it, the telecom themselves. But have they consulted you for your expertise? No, I'd say no. Any Russian media is bigger than us. Russia is a big country, and media are big generators of traffic. Maxim, what about your regulation? Was there any changes? Maxim, am I on? Well, we have our relationships with the regulator. I'm a member of the board of the Internet Association of the Ukraine. And during all this time, there was an attempt to adopt a new Ukrainian law on electronic communications. The amendments to the law on access to infrastructure failed in the parliament. It would have allowed better infrastructure in remote locations, but well, yeah, all regulation that's adopted these days, unfortunately, does not favor small and medium businesses. So that's that. Another thing, something that happened just today. If you don't know, during the weekend in the Ukraine, a very strict lockdown is imposed. During the weekend, there are no supermarkets open, nothing works really. This is done to help people avoid social contacts during the weekend. But pharmacies are open, and there are several other exceptions, and mobile operators were not, or not telecom operators were not included onto the list. It happened already in March. And we fought hard to get ourselves on the list back in spring. And now we have to fight the same battle. We want telecom operators to be included on the list of exceptions. We need the weekend to repair infrastructure, because if people are left during the weekend, I mean, subscribers are left without communication during the weekend. If they can't get in touch with others, if they don't have that communication channel, they will protest. Okay, very well. Then let's discuss problems. Do you see the screen? Well, I think you can take these questions one by one. And if you want to volunteer, you are welcome to do it. What were the problems this year? Did logistic fail you? Did you have any problems with procuring equipment? Yes, there were logistic troubles, and not just were, they are still here. There are fewer customers, and especially paying customers, like small and medium businesses, since many of them went bankrupt. It happened in spring. It continues now, and we believe that as a result of this lockdown during the weekend, so the market will lose many companies in the servicing sector, because like cafes, they get like 40% of their or 50% of their revenue through their work in those 2 days, Saturday and Sunday. But now they are all closed. I can't say that more private users offset the outflow of corporate users, but well, at least there is something there. Exchange rates, I mean foreign currency exchange rates, they too fluctuated, but again, this has had the least impact on us. The operators cannot keep procuring forever. At best, our revenue is not declining. For most of us, we are incurring losses. But the biggest challenge is, as always, regulation. The regulators do not understand that telecom operators are critical infrastructure that must run, and they must service their networks regardless of lockdowns. I agree to service clients, I mean, connecting new ones, onboarding new clients. Okay, you can impose some limitations, but don't break what's not yet broken. And those people who are issuing all these guidelines and instructions, they don't understand it. If you comply with the law, and we all understand that Russian laws and Ukrainian laws, they work best on paper. But if there is a provider of optic lines to all the Ukrainian corporate customers, if they lose a link on Friday night, today they are authorized to begin repairs or only on Monday, and it means that those customers will be without service for 2 days instead of just 2 hours. Dima? Yes, I can also add something to this discussion. We too are looking at some interesting trends. Corporate customers are migrating to data centers. I think that Pavel and all data centers operators they should be very happy today. They should be celebrating. And I think that means that it will be more difficult to make money on access networks. And I think it's a trend that will stay with us for the next year or 18 months. In terms of foreign currency, I can only speak about the Russian market. And for us, it did have those exchange rates changes. It had a big impact on us, and for us it's much more challenging now to invest into innovative programs. Our free cash flow is subsiding and the cost of equipment is growing. We also noticed that vendors, they are not changing their price policies. Rather, they are changing licensing policies, methods of licensing. So no one is actually increasing the prices, but the shipments are down, and globally, I mean, it's happening everywhere. But now they're trying to recover their losses by changing the lines of products that they are offering, and especially licenses and subscriptions schemes. We are a trunk company, and we don't have many small and medium businesses among customers, and we don't have any individuals as customers. But there is the law of conservation of energy. I think that the first quarter of next year will give us a more truthful picture. But right now, yes, we are stable. I have a clarifying question about vendors. Did you have any troubles with equipment deliveries? Because in spring, there were big delays of a month, even longer than a month. I think you should buy a lot of equipment. Well, we are a mono vendor, by vendor company. We have two main vendors, and if you allow me, I can give you names. I mean, if anyone is interested, I can name them. But anyway, we are planning our procurement in a way so that we can get big batches, and this happens 4, maybe 6 times a year. So, and this year we'll already have a plan for purchases next year, because we know how we're going to upgrade or expand our network. So all these locales and everything, all the plans were already in place and everybody knew what the plans were, we didn't have any a bad experience with shipments. But actually, we had more problems with getting access to data centers because people just couldn't travel. So we had issues with deployments and installations and assemblies, this kind of stuff. Any additional purchases? Yes. I mean, the ones that were not scheduled, some sudden purchases. Yes, we had problems, longer logistics, more problems at the customs. Pavel, what did you see? Well, logistics is not just box moving. Yes, some boxes moved slowly, others didn't. We were receiving shipments, but logistics comes in different shapes and sizes. For instance, trainings in Russia are closed. There aren't any flights, we can't send people abroad. And for us, this is an important component. It's an integral part of our operations. Logistics in April, or rather in the time from April, we hired about 130 people. We are 500 people strong company, and this is not because of outflow or churn, or attrition. This is expansion, really. We mostly were hiring engineers and hardware administrators, operating system administrators. So the environment is new, and HR had to adjust. We had several dozens of engineers on duty, the ones who are on duty. All these remote hands, we had to find them, hire them, train them, integrate them into our shifts, and I'm really proud of our HR service. They are accomplishing feats. I understand that people now are working from home and they don't see each other over smoke. But that's one issue. When you already have trained personnel, it's a different challenge. But when you have to onboard new people and when you have to train them, someone who is not yet part of your culture, who doesn't, you know, this is a less obvious but a very powerful challenge. Can I add a couple of words on logistics? In 2020, we planned to build filtering sites, and we lost Toma. Okay, while Toma is reconnecting, Pasha. In terms of your customer breakdown, did something change? Well, we have enough customers for me now to say no to your question. So yes, there is some movement in the customer structure, in the customer base, but I think that the changes in the services consumed by those customers, like more remote working stations and more security, their movement is much more pronounced. The changes are pronounced. But the customer base, no, it didn't change much. Colleagues are saying that more corporate clients are moving to data centers from on-prem servers. We don't see that. We don't see that. There is some growth because some people's offices were sealed off and they can't press the reset button. That's why they decided to migrate to a data center. But for us, these are very few cases. And when Tom is back, yeah, can I say something about the logistic challenges? We are constructing 3 data centers in Moscow as we speak. They're all at different stages in development. We're building in Novosibirsk and in St. Petersburg. We also cooperate with Udomля. We never stopped construction. And data center equipment is heavy, it's big, climatic systems and all of this. It all came on time. It has been installed to the best of my knowledge in accordance with the schedule. Okay, all these construction projects, did you plan them back in 2019 or was this a spontaneous decision? And you realized suddenly that you didn't have enough infrastructure. No. These processes are very long. And of course, they took a lot of design. They required a lot of design. And no, they were planned well in advance. So Toma is back. Logistics. Yeah, on the subject of logistics, there was an interesting challenge that we encountered this year. We planned to build 3 new filtering sites in the Middle East, in Japan, and in Brazil. And we planned to be engaged in those projects from April this year. We almost managed to do this. But that was associated with fantastic challenges. All traveling stopped. We had incredible problems with equipment. For the first time in history, we decided to build one site using AMD processors, not Intel CPUs. But that was part of the logistics challenge. But we also had to send engineers to the respective country, considering that the number of attacks is growing, traffic is growing, and we will need those sites in the near future. It was fantastic. And I agree with Maxim totally. I subscribe to every word. When network engineers are staying at home and they cannot reach their own data centers for an urgent maintenance, This is a nightmare, but there is another nightmare as well when you have to send an engineer to a neighboring country. Well, even if it's not a neighboring country, any country for a setup, and this is out of your reach. It's absolutely impossible, and it's something that we could not conceive before 2020. So what did you do? Did you hire someone at the spot? Oh well, this and that. We used different tricks. We were lucky because we had people in many different countries. In some countries, we're still communicating. But again, those three countries, under this lockdown, we had to become very inventive in our logistics. But every time it was an ad hoc solution. And sometimes we would be shocked about how things worked. I mean, there are two neighboring countries. There is no border between them in usual times. But during the lockdown, there is suddenly a border, and there is a local farmer who, on a tractor would be transporting people across the border. We asked people, how did you manage to get here from another place? And they would be telling us those absolutely fantastic stories of how they crossed the border. I hope so much that I will never have to live through another pandemic ever in my life. Never again. I don't want to have this experience repeated. Yes, crossing borders on a tractor. It's like I heard you all know about the stories how people cross borders. I don't know, Mexico, United States, or Canada, United States. Well, there are so many stories that we could tell. I'm a pilot, and I can answer a different country because I have a pilot's license. I can fly. I can take my small aircrafts, for instance. I can fly to a different country just because I'm a pilot. But even if you're a pilot, you must be in a quarantine, no? Well, pilots can still travel between the countries. And then there are other smart people who decided to get themselves a sailor's ID. And you can get a sailor's ID quite easily, because even if you're a janitor on board a ship, you can have the same access to a different country as if you were master of the ship. I heard another story. Companies got entrepreneurs logistics code. They would add logistics to the list of the lines of business that they can operate. That you have to register those businesses with the registration authorities. But if you have logistics there, then it means that you are in export-import transactions and you can cross borders. Okay, another question. What are the main takeaways of this year? We understand that this is a very unusual year, but we are all worried that 2021 will be, at least some of it will be similar to what we've just experienced. Well, in the context of logistics problems and hiring, for us too, it was an issue because we didn't have people everywhere. And recruitment and hiring, when you have closed borders, when you can't sometimes travel even between cities, when regions shut themselves off. Well, if we see that in a particular place our business grows intensively and we see that business is growing there, people decide to migrate, and we support our engineers if they decide to migrate. Of course, if people are staying in their apartments and they can't step out and get to the data center, that's one kind of issue. But if some traveling is allowed, we try to make use of it. Operationally, we didn't suffer too much, and that's why we do not plan any dramatic changes. There is one thing of which we are suspicious. we are concerned about traffic peaking. We know that now people spend most of their days at home, all their working hours are at home. And Akamai recently had a release, and they said, press release, that that was several years ago, that where traffic really surged. I don't know what release was that, maybe, I don't know why, but those unexpected surges in traffic profile is changing, and to be certain that we deliver it without losses, we have to become even more serious about the traffic. Given that traffic now is or can be distributed differently, given that now aggregation traffic aggregation points are also changing, we have to become even more focused. What else can I say? It will depend on how long this lockdown will be preserved, and well, I hope so much that already in a year maybe we will go back to business as usual and we'll resume our traveling. Artyom, during a conference in spring, you asked people, you had a panel discussion around this topic. What is the progress that you yourselves made in terms of distributed teams? Well, we have always had a distributed team. Well, I think something changed for you too. Well, since we take this very seriously, I mean, the whole pandemic, we closed our offices almost immediately in Moscow and in our other locations. For us, our staff health is a priority. But you see, when we reopened in summer, people flooded the office. I think we all have experience of staying home with our families, with our kids and pets, and it's very difficult to stay concentrated on your work when there is family life happening around you. We closed our office since. We are back to this mode of operation, and some people are lucky and they can dedicate a room for themselves and create an office there at home, but not everyone is that lucky. We're not going to change our hiring policy of that. We know that there is BitLab, for instance. They are only recruiting people who have certain capacities, capabilities of arranging for themselves a quiet working environment. Our company's resources are still sufficient for us to have some freedom still. I understand that when you have thousands, dozens of thousands of people to manage, then probably for those companies things are much more complicated. People are telling me that we only have like 5 minutes left, so Pasha and Maxim, maybe you can say something in conclusion. After that, I will, or not conclusion, but some some remarks from you with respect to this question. Pasha, your microphone is off, and after that, I will go on to the final question. We are quite a conservative company, and we all went to the office 9 to 6, but now I don't think we are going back to the office. We all understand the drawbacks of remote working, but it's still less inefficient than people predicted. We all learned to communicate using video conferencing. Meetings got shorter, so there is a gain in performance. I don't think there is anybody who is still trying to foresee or predict when this is going to end, but we learned to manage under these conditions. And I know that our engineers and I know that we already tested operating in shifts when engineers perform a shift for several days or weeks. I mean, we know how to do it. We never had to do it ourselves, but I think that everybody in the market at least considered such a scenario when you would be installing beds in your, I don't know, data centers or server rooms and keep your engineers locked there for a couple of weeks. So there is someone to press a reset button. Well, I agree that businesses survived. Now we gained experience that we can use in the times of peace, and it turns out that we can all work from home, and perhaps there is a potential for economizing there, for savings. We know how to resolve issues via internet, and I think that many companies have changed for good. Now we needed the only thing that's left for us to do is to bring the message home to the regulators, to the governments, and to explain to them finally, once and for all, that telecommunications is an indispensable service that requires non-stop maintenance. Okay, my final question to all of you. We understand that all companies are suffering, many businesses are in trouble. How did you support your clients? I'd like to hear one case from each of you. Well, in spring, we announced that we will provide free of charge defenses to educational services. We started with education, then we extended this list. We included several more types of service providers. We understand that in the times of lockdowns and the quarantine, the telecom operators, network operators, IT, data centers, they should not stop, but education should not stop either. So we decided that although it's not the most probably business-like decision, but being a socially responsible company, we decided to offer free services to education and then several other sectors as well. Dima? Well, we received many requests to provide exceptions and relaxation of policies, and we did that, and we scaled everybody up. It's all that we could do, and we did it. Pasha? We offered payment by installments. We offered expertise as well. I don't like when people talk about transformation, but when our colleagues or partners' situation changed in terms of their logistics or movement of people, we try to consult them and see which services could support them in those difficult times. Okay, we ran out of time almost. Maxim, your final remark. Yeah, we too provided free resources to people, and we also offered a postponement of payments, deferred payments. Some people abused that offer. That is to say, they paid us one of the last of their providers, but I think still that the industry needs to stick together and support each other. Well, thank you very much for this conversation. That was an interesting discussion indeed. Dmitry Lopata, Commercial Director of Breton, Pavel Zavyalov, Business Support Director, Dataline, Maxim Tulyev, NAT Assist Director, and Toma Gavrichenkov, CTO, Curator Labs. Colleagues, thank you so much. Thank you, everyone. Thank you.
Okay, well, many thanks, everybody. That brings us to the end of the sessions today. It also brings us to the end of ENOG 17 as well. So thanks for everybody that's joined us this week. Hopefully it was useful and you haven't been overwhelmed with too many sessions, online sessions. We did try to keep a happy balance between trying to provide some information and not trying to overwhelm everybody. And hopefully we got it right. But I'm going to hand over to Alex. She may already be talking on another channel.
So I hope very much that those of you who joined ENOG 17 for the first time and live this year, you will be back for ENOG 18 next year. One thing that makes me sad is that our spatial chat, our comfy spatial chat that we advertised every day was not very popular among the participants of the conference, although I find it to be a very good communication platform, because ENOG is not just a conference of presentations, it is also a networking event. Hopefully next year we'll find a better, a more attractive solution for you all, or you will find spatial chat a more attractive solution next year. So thank you very much. This conference is over. We will keep you posted about our activities for next year. Please stay in touch and enjoy your weekend.